Yeah, good afternoon, and thank you for joining this very interesting session. So today we are talking about the marine logistics, and uh, I can say personally I am Gautam Sinha from Director General of Hydrocarbon. I am an advisor there, but with my experience in Bombay High, I worked in Bombay High for almost 15, 16 years. I know the importance of marine logistics in offshore. So offshore operation is entirely dependent on the proper supply of the material, equipment to the fields, to the rigs, to the platforms for a smooth operation. So we have very impressive speakers today lined up, and each will be allotted 15 minutes for the presentation. But before, to just set the context, before they start the presentation, I'll take 2-3 minutes to give you some numbers. So world over, whatever trade is happening globally, so 80% of the movement of cargoes is through marine route. So it's a very impressive number. 80% of global trade, merchandisable trade happens through the marine route. And for the India, it is almost 95% in terms of the volume and 65% in terms of value. In 1990, almost 3 decades ago, the global trade volume through the marine route was 4 billion ton, but it has become 3 times. It is almost 12 billion tons in 2020. So you see that there's an exponential growth of marine logistics and marine volume, and all across the world, the marine trades are happening. Now, what is happening that the marine industry is facing a big challenge in terms of decarbonization, increasing the efficiency. Now they are actually deploying a lot of new technology like AI, data analytics, then probably blockchain, and increasing the efficiency and at the same time reducing the carbon footprint globally. So we have good presentations lined up today, and there will be no question answer session because of the limitation of time, but all the speakers are available after the session. If anybody wants to discuss with them, they are welcome to discuss, and they can have their contact number for the discussion. So before I introduce my speakers, I'll start with Minal. Mr. Minal Dutt is a very impressive experience. Is from GAIL, Gas Authority of India Limited. He has 16 years experience in shipping of and oil and gas industry. He worked as an LNG marine engineer in Mitsui Oil Line, Tokyo, and he has done MBA from IM Indore with the first class. Now he is working in GAIL. So his topic will be opportunity in a crisis, GAIL's optimization, response to Red Sea crisis. Minal, the floor is yours.
So, what do you actually do when a crisis strikes you? While some people lay low and curb their ambitions, while some people take this as an opportunity to expand to the next level. Prime Minister of India yesterday talked about the 5 pillars of energy strength of this country. Now, this through this case, we will demonstrate that how using all these 5 pillars, GAIL has been able to tide through the Red Sea crisis, but not only toward through the crisis, it also developed a significant strength in the European market while still preserving the interest of the domestic consumers in India. Now, a brief on the Red Sea crisis. This crisis occurred in at around Q4 of 2023 when Houthis started attacking the commercial ships, and the Red Sea and the Suez area become an area of peril, and the passage through the Red Sea area got severely impacted. Now, the effect on LNG was far more striking. So the figure what you see over here is actually on the left side is the passage of vessels before the Red Sea crisis occurs in November 2023, and the right side is the figure after the crisis actually happened. So before the crisis, on a monthly basis, approximately 100 vessels travel through Red Sea area. After the crisis, this almost came to nil. Now, in order to understand how it impacted GAIL, you first need to understand how GAIL operates. So we have FOB contracts from United States, and these for us to bring these volumes to India, the Suez Canal is the shortest route. So our vessel loads from USA, goes via Atlantic Ocean to Gibraltar, and then through Mediterranean Sea and the Red Sea and Suez area via Gulf of Aden to India. Now this voyage takes approximately 24 days. Now since this voyage is this way is no more acceptable to us by the it's very dangerous. So the other route available to us is via the Cape of Good Hope. Now this route is more than 2,000 nautical miles longer. So from 10,000 to 12,000 nautical miles, the journey becomes 30 days. Now, in order to appreciate the impact of this, you must first understand some of the nuances of LNG trade. In LNG trade, the cargo schedule for the loading as your discharge terminal, date wise, is fixed an year in advance, and this remains fixed for the whole year. So for Sabine Pass and Cove Point, if I have the loading date say on 1st January and next 50 days onwards, this is fixed. I have to meet this obligation. So what actually happens in this? So as the ship, as the voyage route is longer, first it leads to increase in shipping cost. Now, as I'm not able to fully utilize my ship for the required number of volumes to be lifted from USA, this leads to me from being balanced to short in shipping. The third, which is a very difficult thing to handle and which is peculiar to LNG trade, is the mismatch in the cargo schedule and the vessel schedule. I will explain in detail in the next slide, but the three problems happens: idling of vessels, arrangement for additional freight because we are short in shipping, and when the schedule is not being matched, you need to source the volume. Now, when you are required to source the volume and you are required to do additional freight, you are exposed to market volatility, which is extremely high LNG trade. So let me show with a voyage example how this happened. So day 1, the vessel is supposed to load. On day 24 or 25, the vessel will discharge. Day 50, the next loading. And day 75, it goes for the next discharging. Now this is fixed an year in advance. All the slots are big, both on the loading side as well on the regas side. Now just imagine what has changed now. On the day 1, you are loading. On the day 24, 25, you don't have cargo available. So what you need to do is you need to evacuate the cargo from the loading terminal, plus you need to also evacuate the cargo from the discharge side because your commitment remains intact. Now the vessel cannot come in time, so you have to manage. Maybe you have to buy a cargo for the 25th day. Because how do you meet the domestic demand in the India? Secondly, when on the day 50, when you are required to be there at the loading port, you are not there because the vessel cannot reach in time, and hence you might need to hire an additional freight. So these problems happen, and if you want to maintain the vessel for the next loading, you have to idle the vessel for a very, very long time. Now, just try imagining the situation with just one vessel. We have 3 vessels in the fleet. So this becomes a big jigsaw puzzle, big jigsaw puzzle. You see on the every second row of each vessel on the oval mark I have put in the presentation, this is where my vessel is not reaching in time. And on the right hand side, what you see is the discharge schedule where either my vessel is not able to reach in time or I have to wait a lot. So in all together, this was a big problem for the whole department. And I have 2 gentlemen sitting over here, a part of this team. So it was a big headache. How do we get over this crisis? So we thought is, but the other problem compounded by this, there is, so one thing you could very easily do is for whatever period you don't have the vessel coming in time, you could do a spot chartering. But the problem in that time was the spot charter rate was close to $150,000 to $200,000. And for each loading, you would have an additional cost of minimum 4 to 5 million US dollars. Now, if you do an additional charter of the vessel, what do you do with the vessel which doesn't reach in earlier? So you have plus the idling cost. So in altogether, we are looking at a financial implication in one quarter close to 20 to 25 million dollars. Now, what do we do? So let's, I mean, till now, what? So till now, what what we have been doing is using shipping as a support function to trading function. So what do we do? If the cargo is not arriving in time, hire another vessel. But what if we turn the table around and use shipping as a strategy that yes, we will not hire a vessel. We will try to find a solution within our limited constraint. So what Gale did was use a multi-pronged strategy. So first thing we were supposed to do, we took a proactive decision of not letting the vessel pass through Suez Canal, and we did not take any last-minute decision. It was a planned decision to not uh, allow the vessel to go through Suez Canal even before the Shell, BP, and Total did it. So that was one strategy from our side. Second is, since we had three vessels, one vessel we diverted through Cape of Good Hope, wherein the vessel did from the bottom of the towards from the Cape of Good Hope. And for other two vessels, what I'm going to explain to you is we did the des swap. It's a very interesting concept, and Prime Minister of India, in his speech in the first three pillars, he said that your own resource is very, very important. Second point, he said that we Indian have an innovative mindset. And the third thing is very, very important. He said that we have a strategic geographical location. Now, this example will show you very shortly how each of these three concepts we did to arrive at a very significant solution for us. So, if if you have to arrive in time, you can't come to India. Now, what's the nearest market to the US terminals? That is the European market. That market you can reach in 15 days' time. If you reach that market in 15 days' time, you can do a round trip voyage in a 30-day period of time. So, what did you do? You actually reduce the shipping cost, and you also make the increase the utilization level of the vessel. But we are an energy starved country. So we need, these volumes are all marked for India. So we need to also buy a similar volume for the Indian market. So what we did was, and as geographically India is so well inclined that we have Qatar, Australia, and so many other sources nearby where LNG can come from. So we did something called as a des swap, in which we sold the volume on DS basis in Europe and purchased the corresponding volume in India. So these cargo were sold on delivered in Europe, and the corresponding brought in India. Now, as I told you, the shipping cost is saved because we are able to do two trips instead of one. One more thing we wanted to do was, whenever you want to do something new, you are exposed to newer risks. Like when we talk to parties, they said that if you sell us on the European index, the acceptability is more for your cargo. So the first time also we did one thing was sold the cargoes on TTF index, the index which is actually most powerful, most prevalent index in the Europe. That's the TTF index. And to naturally hedge our position in India, we sold at TTF and we bought at TTF. Now, TTF is a very, very volatile market. You would appreciate that though I am saving cost on shipping on US front, but if I have to pay an additional price for those cargo in India, which is more than the shipping cost, I will not be making money. So to have all the deals to be in the money, we had to time the market carefully to take benefit of this east and west arbitrage. Now, this east and west arbitrage is extremely volatile, extremely volatile. This, what you see on the red lines are the spot rates, and the blue orange lines are the difference in TTF and JKM. So if you look carefully at the period from November 20 through close to November 23, the difference is not much. It's moving quite a lot in between those two periods. So arriving at a sweet spot when your inquiry will be in the money is very, very important. I will explain this through a case in which you see a sensitivity analysis in front of you, wherein on the row side you have the charter rates 5,000, 50,000, 75,000, 100,000, 125, 150, and on the other side you have east-west arbitrage. What is the difference between the price between the Indian market and the European market? So what you see carefully, if the Indian market is priced at a very, very high level, like arbitrage is 1.5, 1, more than $1, we will not be saving a lot of money. So it's very, very important to time the inquiry in such a way that uh, these uh, these optimizations are in the money. And uh, I will be very frank with you, in some of the inquiries we could not achieve the level, so we failed also. So we tried again, because we are a government company, we have to follow procurement procedure. So this is additional challenge on us. So this timing was a very, very tricky case, and we did close to around 7 transactions in in the in that particular period wherein we were handling the Red Sea crisis. And what you have here is the total saving in round trip distance. When you see all the cargoes for the vessel Cool Blizzard and Grace Amelia went to Europe, and when we take into account the distance traveled by the vessel which actually traveled the cargo to India, the total saving in distance was 43,200 nautical miles. This led to the saving of 34,600 tons, which makes the point to the two important pillars which Prime Minister talked about, is that you need to, India needs to harness the economic and technical strength. And the last and important point he said was economic sustainability. So the first pillar, that you need to have used your own resource. We did not charter the vessel from the market. We used our own resource. The second thing he said was innovate. We innovated using this desk unique optimization to arrive at a solution. The third thing he said was use the geographical advantage to India, which we used it very well. The fourth thing was your technical and economic strength. You might have all these ideas, but if people are not willing to buy from you in the European market, this idea is of no use. So this is where the reputation of India and GAIL as such, where when we float an inquiry into the market to sell the cargo in Europe and buy in India, the whole world lines up to buy it. So that's the fourth pillar. And the fifth and most important pillar, this whole dimension led to a sustainable solution where we set significant cargo emissions. These are actual maps. These are actual maps from the deals where these vessels, which are supposed to go via the Suez and Cape of Good Hope, ended up traveling onto the European leg. And Cool Blizzard almost did the entire voyage on Europe. So what is the solution? What is the results we achieve? We lifted the entire US LNG volume in time. Cargoes were supplied in India as per the schedule. No additional chartering of vessel in a tighter winter market. It was a very tight winter market in that time, not like now. No increase in overall shipping cost, overall increase in vessel utilization, and an opportunity to expand the trade in European market and still preserving the domestic interest of consumers in India. And so the most important, use shipping as a strategy, not just as a support function. When you have your own fleet, you can do all these things, rest all things, and use your mind to innovate. And the 5 pillars which Prime Minister talked about, very, very, very well explains in this presentation. Thank you very much. Jai Hind.
Yeah, Minal, thank you. A very good presentation and the innovative idea taken by GAIL. Not only reduce the cost, but reduce the emission. That is very important. So our next speaker is Paramjot Singh, and I'll briefly talk about him. He is a managing director with energy practice at Accenture India business. He has 14 plus years experience in consulting in industry. Before joining Accenture, he was working with Schlumberger. So Paramjot, the floor is yours. Vessel hiring optimization is his topic.
Thank you so much, Chairman sir. Good afternoon, everyone. First of all, thank you very much for having me here today at the India Energy event. My name is Paramjot. I am a managing director with Accenture. At Accenture, we undertake a lot of digital and analytics-led transformations, and a lot of those transformations are actually focused at supply chain, logistics, and operational excellence. Now, leveraging learnings from some of these engagements, we have built an in-house solution, which is directed at the marine industry, specifically on how we use AI/ML to optimize the hiring of vessels. While I'll go into a bit of detail of this solution, I will just maybe start with one slide, giving you an overview of the vessel industry in India. As India strengthens its position as a global trade hub, the demand for marine vessels for cargo transportation is only expected to increase. Today we have about 90% of India's trade, movement through maritime transport. There are about 1,500 vessels, across oil tankers, LNG carriers, bulk carriers, which are plying in our seas. The industry overall is stated to, grow at a healthy 8 to 10% CAGR. So I think we are sorted there. The government of India also has taken some very good initiatives like, the Sagarmala project to boost coastal shipping, reduce logistics costs, and so on. There are initiatives like Panchkarma Sankalp, which are focusing on now green shipping and digitization. In addition, there are initiatives to develop over 26 inland waterways, which will be a very cost effective alternate to a road and logistics transport. However, even after all these initiatives, there are few challenges which still haunt the industry. When it comes to the pricing, the spot pricing, especially in periods of high demand, it shoots up drastically. So it's very difficult to say get vessels on spot. Demerit charges, detention charges are one of the highest in the world. On an average, an Indian vessel pays about $435 per day per container as a demurrage charge, which is actually the fourth highest when it comes to in the world. The vessel utilization again is pretty low. We are in early 50s. So there is a lot that can be done. And with AI, with digital coming into play, I think some of these technologies can help to bring some value to give some pointed solutions to the vessel hiring in particular. And then that's where the solution that we have developed in house, I'll come to that. Now, vessel hiring optimization is a digital and advanced analytics based optimization engine which helps for vessel hiring, routing, and scheduling. The solution aims to basically provide you the most optimal vessel hiring plan and the movement plan. Uh, of course, this is against a particular demand that you feed in the system, and it balances against a set of constraints as well as the objectives. So essentially, the key questions that we are trying to answer, one is, for a given demand, what is the number of vessels that you need to contract? Second, what is the most efficient route that they ply on? Third, what is the kind of product configuration? What product goes in what tank, and so on. And finally, what's the most cost optimal split between your term and your, voyage charters, basically. The key benefits that we are trying to sort of bring through with this solution, one is of course around increasing the utilization of vessel. Second is identifying the best routes within the set of constraints that your firm may have. uh, Reduce basically stockouts and dryouts. So to the extent possible, try to fulfill as much demand as possible. And then of course reduce my cost per metric ton of shipping, and enhance my cost efficiency when it comes to shipping. Now, just going a little bit in detail of this solution, the solution framework is based on Bayesian optimization technique. This is a advanced analytics based algorithm. So there are four key pillars. One starting with data, where uh, of course we take the input data when it comes to the demand plan of what your firm wants to take from point A to point B, and thereon. But there are other informations like my vessel, my product, my historical movement, my pricing between spot and term, etc., which we basically collect at the very start. The next step is where the analytics starts to generate some trials for a particular route, a product combination, and so on. uh, we overlay this with a set of constraints. So constraints, those could be around operations, around products, around port. There could be certain ports where you would have certain draft restrictions. So all those about 20-25 constraints that we determine with our client actually goes into this solution for determining the best route. And finally, the optimization framework kicks in, where like I mentioned, Bayesian optimization techniques are used to dynamically attribute scores to multiple objective functions. So it's not like we are only say maximizing say cost efficiency or service level or turnaround time. So there are multiple objective functions, about 5 or 6 that we have defined in the current solution, where basis the constraints, basis the objective functions, we try to come to an optimal solution. Now I'll deep dive a bit into each of these solution elements, starting with the data sources. So like I mentioned, there are data sources that we take. One of course is starting with your demand plan. What you want to move on what routes. Uh, then it is what products, so which product can get mixed with the other, their densities, their volumes, and so on. The third important category is around the historical prices for hiring of the vessels. Now this is a combination. If you look at some trends around how the spots are evolving, as well as how your past historical contracts with the different charterers have been. The other important part around the vessel cost is around the operational cost. So one of course is your fixed cost that you would incur for getting these charters on a term contract, but then there's also a variable cost of operations that one would want to explore. uh, in this particular model, we also ingesting some external data. When it comes to the weather patterns, economic indicators, currency exchange fluctuations, all of that also is something that we are incorporating. Uh, then what are the different configurations of the vessels? Their flow rates, their compartments, their vessel capacities, past charter agreements, any disputes in the past, and so on. And then finally, details around ports. So when it comes to the draft restrictions on the port, what tankages they have, what have been the historic idling times that the charters have had on that particular, and so on and so forth. Now, a lot of this data, feeds into, of course, my objective function as well as my constraints. So the constraints that we're basically looking at are, constraints around vessel utilization. So I can actually define in my model what is the bare minimum utilization that I am looking at. What kind of speed, what kind of efficiency I'm looking at, what sort of in case applicable dead freight penalties that I incur. Some of those vessel utilization related constraints I can build in. The other important aspect that comes in is around the product switchability. So in a lot of cargoes, you will have to incur a cleaning cost, both cost and time, to actually change or switch the product. So those sort of constraints are also something that we are able to build in the model. uh, there are then constraints around port delays, idling, uh, like I mentioned earlier, constraints around port drafts, cargo handling limits, etc. And then of course, what is the constraint that I have when it comes to my demand fulfillment? Am I looking at certain service levels to meet? Uh, are there any say customer specific deadlines that I need to adhere to, and so on and so forth. Now, the final step, of course, is the optimization engine that sort of kicks in. So like I mentioned earlier, there are multiple objective functions that the model is able to dynamically assign some output to. Now we have the luxury of tweaking some of this, and basis the requirement of our customers, tweak some of these configurations to prioritize one objective function versus the other. uh, so there are points around cost optimization, how I want to reduce my per metric ton cost of shipment, in case there are any deviations that I'm allowed. So those also I can incorporate within the objective functions, and so on and so forth. Uh, Now, the sample output that we are able to basically give with this solution is on these 5 dimensions. The first one is, you know, for that demand within those constraints and the objective function, what is the number and capacity of the vessel, that I'm looking at? Uh, and what's the recommendation on the contract? Should I go for a term? How many, if I want to go for a spot, how many, and so on. The second is the product configuration by vessel. So in which compartment, what do I store, in what particular trip, and so on and so forth. The third is the movement plan. So if I have to go from port A to port B, unload something, pick something, go to the next port, so that entire journey plan, for that particular demand, we're able to give as an output. The fourth is, of course, what is the most optimal route that the vessel takes. And finally, certain metrics around what's my cost per metric ton, how should I, mix my spot versus term, the average utilization, and so on and so forth. Now, the benefits that we have seen with this solution in some of the past engagements where we have delivered this for some of our global clients, the vessel requirement actually typically would come down by about 20%. So today, if I am say hiring 10 charters, I can actually make do with 8 of those. I'm able to reduce my cost of movement, optimizing my spots and terms to about 15%. The utilization, has seen a significant improvement. And finally, when it comes to the service level on adhering certain, demand fulfillment that, we have been able to, address. Now, of course, there are these business benefits, but then, this whole optimization is actually a very, effort intensive work. So with this solution, we have been able to make this, quite faster and help, some of our clients to do this in a more optimal and a quick, turnaround manner. Uh, Finally, we have created an asset out of it. There is no need for the user to basically go and look through what Bayesian does, how the optimization happens. So all of the screens that a user is exposed to are basically very easy, where they would typically go and add the information regarding what their requirements are. uh, they're basically able to put what sort of demand projection they are looking at, what sort of movement that they're envisaging from one port to another. uh, and of course, finally the output is something that I spoke about, of actual physical movement, the plan for it, by vessel, by trip, for the demand that that the client put forth. So yeah, that's my time. Thank you so much for having me here.
Thank you, Navjot. Very interesting presentation. So before I start, because I know the need for optimization in offshore, because I was in offshore for 15 years. So what we have seen that the company might have a large number of vessels at its disposal, but if their movements are not properly planned, a lot of rigs wait. There are a lot of non-productive times in offshore rigs or platform. Some of the vessels are idling at one of the rigs and the crane is not operating. So the vessel is standby at the rig, whereas the cargo for the next rig is there and he is not able to deliver the cargo to the next rig. So these are the problems and where the optimization actually plays a very important role. And nowadays, because of the machine learning, AI, data analytics, and blockchain, a lot of companies are doing the online monitoring of the vessel and optimization. So coming to our third presentation, a very interesting presentation. It will be a joint presentation. We have two officers from Engineers India Limited, Mr. Shashank Singh and Mr. Neeraj Shrikant Morgaonkar. So I just briefly talk about them. They are this thing. Mr. Shashank Singh is AGM Contracts and Purchase EIL and is a graduate mechanical engineer and an MBA. 17 plus years experience in contracts, large scale projects, gas, fertilizer, petrochemical, metallurgy. And Mr. Neeraj is a production engineering graduate, masters in business administration and finance. He has also 17 plus experience in procurement of EPC and energy sector. So I think Mr. Singh, you can start your presentation.
Thank you, Mr. Sinha. I am Shashank. Myself and my colleague, Mr. Neeraj Borgaonkar, we will take you through this presentation on integrating sustainability into procurement. The topic is a different one compared to what we have seen the previous speakers. but nevertheless very important. So, uh, the image in front of you, this depicts the various pillars of sustainability, namely economic, social, environmental. The economic, we talk about increase in production, efficiency, circular economy, job creation. In the social pillar, we talk about how to reduce poverty, hunger, health and education, DEI, peace and justice, ethical issues such as how to check corruption, improve labor practices, and all. In the environmental pillar, which is most talked about of late, we talk about how to maintain healthy ecosystems, climate stability, triple R, reducing carbon footprint, air quality, water usage reduction, energy conservation, etc. So, when all these aspects are taken care in your procurement process, that is what we call sustainable procurement. So, traditionally, the procurement used to be based on the lowest cost basis, the cost and the schedule that we used to ensure, and then we used to place order on the whoso is the lowest bidder. Still, majority of procurement is done in this mode only, but nevertheless, in the modern procurement, we also have started to give weightage to the quality aspect. So there is a certain threshold beyond which the quality is being offered. We give some weightage to that, and then we arrive at our decision whether to which proposal we place the contract. Now, in the sustainable procurement, our intention is not just to consider the existing factors, but also to include sustainability parameters. So MEET is a abbreviation for that, most economically advantageous standards. That is a term. So many of the global bodies like World Bank, like United Nations, they all have defined procurement in similar fashion. So if we map the SDGs of United Nations declared since adopted since 2015. So there are 17 goals over there. In all these goals, there are certain roles the sustainable procurement can play, but SDG number 12, that is specifically about responsible consumption and production. If we further go deeper into SDG 12, we have SDG 12.7, which is there for the policymakers and for the public procurement entities. It emphasizes on adoption of sustainable procurement, which encompasses green public procurement and socially responsible public procurement. So this is just a conceptual model to explain where and how an entity, any manufacturer that can leverage its SP, that's an abbreviation for sustainable procurement, uh, in its value chain. So any manufacturer, there can be a large suppliers, well-established supplier, and there are some small suppliers who are maybe MSC, micro, small, medium enterprises. Similarly, in the downstream side also, you have small retail consumers are there and corporate consumers are there. So in case of large supplier in the upstream and the large consumer in the downstream, we are not really worried because they already have their internal sustainable processes in place. So our SP might be, their internal process might be better than our requirements. So, but in case of small suppliers who don't have resources and know-how, in that scenario, our uh, SP sustainable procurement policies can handhold them, and so that their overall processes are cleaner, are sustainable. Similarly, in the downstream side also, our extended producer responsibility, that is a complementary term for SP in the downstream side. In case of smaller consumer, like retail user, you can have your EPR influential, maybe by producing energy efficient products, by products which are uh, low on environmental impact at the time of disposal, by biodegradable packaging and all. So there are many reasons why to adopt sustainable procurement. It starts with the reputation, risk reduction, your environment responsibility is there. In the long term, it also ensures revenue growth that has been found in many of the research. But apart from that, there are disclosure frameworks implemented in India. Also, we have BRSR. Globally, GRI was there. Now, corresponding framework has been implemented. Say 2 3 years. Many of us might be aware of that. business responsibility and sustainability reporting. So that has been mandated by SEBI for now it has been extended up to top 1000 listed companies. There, in these disclosures, we don't only need to declare our internal processes with respect to sustainability, but also our value chain disclosures are required to be disclosed over there. So that if we see there are some more than 100 data points we have to declare in the BRSR, but out of those, we can't go point wise point, but we have filtered out these are the data points which are applicable solely towards your supplier, towards your value chain. So to have a a good disclosure, a good ESG score, we can environment, social, and governance score, a good and robust sustainable procurement policy can go a long way, so that you have a high ESG rating when you are evaluated. So now let's see. There are four stages broadly in which we classify our procurement process. First one, we start with the pre-qualification stage. Here, the bare minimum requirements such as there are many ISO certification applicable for sustainability, like ISO 14001 is for HSC, ISO 26000 is for social responsibility, ISO 20400 is a specific standard applicable for sustainable procurement itself. So by ISO 2400, we can ensure that down the line procurement process is also complying towards sustainability. Then there can be criteria like exclusion of bidders who have violated certain environmental convention or social convention or human right records. They don't have good human right records. Then ratings are there like MSCI BB rating for ESG. That these are the criteria which one can. This is just a demonstrative. One can incorporate in the pre-qualification stage. Then comes the tender specification stage, where we freeze the tender specification. Here, the indenting, whoever is the user department of your organization, they should be encouraged to put up more and more sustainable material, like recycled material. Then eco-label requirement can be prescribed for all items like electrical items. We have B triple B star ratings are applicable. There are other now already this eco-label program has been implemented by Government of India, so that more and more items sooner it will be there for a lot of material being procured. And then there is an emerging trend of asking for universal design, which will help towards circular economy. In the third stage, that is the bid evaluation stage, two concepts, if I may also, can be introduced, like assessing your supply with respect to sustainability and then life cycle costing. So life cycle costing is for what is being offered, and sustainable criteria is basically for how it is being offered. So we will, we will go through the LCC part in detail in the next slide. But by incorporating these aspects, LCC and apart from the usual requirement, of course, technical score will be there, price factor will be there. So we will combine all these aspects, and then we can arrive at the overall score based on which we can take our procurement decisions. In the final stage, that is contract execution stage, of course, there are what contractual requirements will be there vis-a-vis the commitments made by your supplier. But apart from that, we need to handle supplier for reducing their carbon footprint during construction, maybe during to improve the HSE practices. And one more thing, that is not contract execution here. It's not limited only to the contract as such, because we are doing the life cycle costing, which goes throughout the life cycle. So we need to monitor the product throughout its life cycle. How we have assessed at the time of LCC evaluation, bid evaluation, whether it is behaving the same way or not. That monitoring is required throughout the life cycle of the product itself. So here onward, I request my co-presenter Neeraj to please take over and continue.
Thank you, Shashank. Taking things forward in our topic, integrating sustainability into procurement, the important concept is life cycle costing, under which we factor in the total lifetime cost of any equipment at time of purchase. If, as we see in the diagram, we need to consider pre-acquisition cost, total initial cost till disposable cost. Having said this, it is difficult to integrate or the estimate all the cost at time of procurement. Hence, this costing, life cycle costing is called as cradle to grave costing, as it's from end to end. In this manner, it touches to the basic two pillars as we have seen in our first slide towards basic pillars of sustainability. First one is economic, as it covers overall costs, and second one is environmental, basic fundamental pillar of sustainability if we consider the environmental cost. However, it is difficult to find out the cost in the initially. Another important concept in the life cycle costing is disposable cost. Oftenly, disposable cost is always ignored. However, buyback price, if we seek at time of bidding, while quoting the price from bidder, then the aspect of disposable cost will cover. It is difficult for long life cycle items to take buyback price at initial stage. However, rapid changing technology items or let's say electronics item, it is very easy to seek buyback price from supplier initial phase. That's why this concept leads towards the circular economy, which is the basic fundamental, one of the fundamentals we can say for life cycle costing. Moving towards the public procurement initiative worldwide, due to technology and advancement, the developing countries are lagging behind and developed countries are ahead than other world. Example, EU, Japan, New Zealand are well ahead. They have enacted sustainable public procurement legislations. In Netherlands, there is CO2 performance ladder called as CO2 PL, wherein bidders have been rated as per level 1 to level 5. And depending on their level, the purchase preference is given at time of selection of supplier. Going down to our country, India, the sustainable public procurement landscape, if we look at it, it has got a massive scope because our public procurement constitute 30% of our GDP as compared with 10 to 15% for developed countries. So sustainable public procurement has tremendous scope towards attaining sustainability. As an initiatives, we have highlighted major initiatives over here. First one is e-procurement, which has seen a massive success. Earlier it was central public procurement, even though now it is also functioning, it is migrating towards the GEM portal, that is government e-marketplace. Government public procurement guidelines have been issued by Department of Expenditure through its various manuals, which enables procuring entities, government bodies, PSUs to incorporate factors of sustainability such as life cycle costing methodology, eco mark label requirement, B star rating or minimum energy efficiency for electrical equipments, and EPD, that is environmental product declaration as per ISO 14025 as a type 3 declaration. These are few of to state over here. Moving down to social aspect of sustainability through government policies, it is well taken care in our policy already because these objectives are already overlapping with objectives of social welfare state. It includes promotion of micro and small companies under MSME order. For domestic production boosting, we are having Make in India policy, under which uh, sector-specific policies such as domestically manufactured iron and steel policy, DMEP for electronic product, DOT for telecom product. To boost innovation and to promote the entrepreneurship, we are having Startup India policy also. Government of India has also adopted Integrity Pact
Yeah,
program,
your time is
which
up, so just fasten.
yes, so which ensures integrity pact program over there. Nevertheless, challenges are also associated with sustainability into procurement. First more is resources, as it is long-term gain. So effective change management is required. Competing procurement priorities. As we know, procurement objectives are right quality, right time, right place. So sustainability also been given the objective as such to be called as. And another ones are complexity, policy framework, and lack of measurement. we at EIL are well poised towards moving towards sustainability. We have declared our net zero target by 2035. For our own initiatives, we have waste to fuel, that is CBG plant, solar installations, and Miyawaki forest at our establishment. For our business offerings, we have biorefinery, artificial intelligence based software system at site for HSE, ENG CO2 Chitran software for emission control, and green transition. We are complying with life cycle cost assessment as well as digitization. With our various arena of businesses, we are moving towards clean energy project along with infrastructure project. Thank you. Thank you so much.
Yeah, thank you, Neeraj and Shashank. And it's a very good presentation. So, our oil and gas industries are, as has been told by Neeraj, billions of dollars of equipment. But how many of them are really following this sustainable procurement process, which is very much required for reduction of scope 3 emission? Now, next presentation is by Dhiman, Mr. Dhiman Bhattacharya from EIL, and he is basically a CNI engineer, more than 20 years of experience in oil and gas sector, project management and supply chain. So Dhiman, can start your presentation.
Thank you, sir. Thank you very much for giving me such an opportunity. I'm talking about the digital supply chain management. Good afternoon. Good afternoon to all of you. Today, I would like to talk about a transformative concept, which is reshaping the way that normally the supply chain management works. That is the digital supply chain management. It is nothing but it is a usually a conventional supply chain management is a series of steps in a coordinated network which encompasses all the stakeholders from the manufacturers, from the suppliers, from the distributors, from the end users, and the entire sourcing of raw materials up to the dispatch of the raw material in such a way that it will do finally complete the product within a schedule and cost. But the major challenges faced in this conventional supply chain management are: first one is the inherent challenge, those that depend on the local and international guidelines, the disruption, natural disasters, geopolitical events. One of my friends from GAIL has already told regarding the Suez Canal obstructions, and the increased cost that is due to the inflation rising, and ultimately it is going to impact in the freight forwarding cost, evolving the customer demands, etc. Now there are also some sustainability and environmental impacts are there on the SCM also. The first one is by reducing the cost itself, by minimizing the waste, the energy efficiency that will be in terms of the green energy, energy saving solutions, like in electrical system we can go for the VFD operated drives, the sustainable packaging which should be the biodegradable, and finally the carbon footprint reduction. We know that in our government of India, according to every PSO is having the target to reduce the net zero target by individual target. For EIL, it is around 2035. The third is that the integration of the transportation, warehousing, and distribution. These three all together making a one of the pillar for the entire supply chain management, as well as along with the entire system, we need to identify the risk and disruptions which presently we are facing in the present supply chain conventional management system. The risk management, the contingency planning. Contingency planning should be there as well as for the alternative supply sources as well as during the continuity operations of the disruptions. And supply chain diversification also for sources itself as well as for the end user users. Now, why digital supply chain management it is required? Basically, the challenges which have been confronted by the digital supply chain management, those are increasing, it will counteract the increasing customer demands, it will incline with the globalization and supply chain complexity, the entire technological advancement in terms of digitization and automation, and finally disruptions and uncertainty. Here we can see the two picture. The first one is the traditional supply chain management. Here you can see that the item operates rather travel in a linear fashion with each step dependent on the previous one. The linearity can lead to a significant delay, a certain setback, or any delay in any of the initial steps, if it has not been unnoticed for a few weeks or days, that is ultimately accumulated and considered all together in the final product dispatch. The same way, if we go to the digital supply chain management, it is going to narrative our earlier approach, and the entire system will work in such a cohesive manner in an integral platform, so that all the stakeholders are going to interlink with each other individually, and they are going to exchange the information individually, so that the entire thing, any delay, any disruptions, any uh, unforeseen, you can say unforeseen troubles, that can be complied and that can be mitigated in one state. The DSCM includes the following major features. One is the end-to-end visibility. This is basically the ingestion of the real-time data in periodic intervals and ingestion of the internal systems with the external data in DSCM. So this will give you the entire, from very starting to the dispatch of the material, overall view, and any discrepancies there or not. Agility. Agility is nothing but, in today's market scenario, agility is very much required, and it is going to expedite from day to day. The automation. The process automation of the DSCM, the process automation of the DSCM, it is basically reduce the repetitive task in the supply chain management. It allows to collect, monitor, and provide the real-time data analytics by an automated software without need of laborious pre-planning, which are used to be done in our normal supply chain management. Then improve decision making. Basically, improved decision making is only possible because in digitalization of the supply chain management, we used to get the real-time data and as well as the real-time data analytics itself. So which will enable us for the improved forecasting as well as to reduce the final risk. Now, if we go for the digitalization in the supply chain management, what are the tools we are going to use basically? The first one is the adoption of the IoT driven devices for the supply chain optimization. These IoT driven devices is nothing but these are all at the activated RFID tags, BLE tags, which are being installed in the field all hardwares as well as in the field networks itself. What does it do? It basically giving us the supervision data continuously for the installation for any of the hardware installation, commissioning and operation of the field hardwares, providing the real-time updates, troubleshooting and RCA root cause analysis during operation at site, utilizes the GPS tracking and give us the real-time data for any ODC or long lead item consignment tracking which is coming from country to country, and emphasizes the monitoring of the manpower deployment as shop as well as at site. Enhance the network connectivity also to the cloud system, which we are coming to in the next slide, for the individual respective items. The another tool which we are going to utilize, that is the adoption of the blockchain management. This blockchain management is nothing but this is majorly uses in the transparent procurement system. This is basically give you the this is basically give you the integrity and provenness of the compliance in any of the purchase or procurement section wherever the user, the buyer, the seller all are interacted in a single platform. Then implementation of the cloud-based systems. This is basically a scalable and secure cloud infrastructure where the entire system, all stakeholders are connected in an integral platform and they are working all together. Then the implementation of the AI-driven demand forecasting. That is a AI algorithms in the supply chain management that analyze the vast amount of data, identify the trends and predict the future events. It will also optimizing the supplier selection and performance tracking, and finally leveraging the predictive analytics for risk mitigation. Now, as a part of the digitalization in the supply chain management, in some of the cases in India, we have implemented some systems already. So those are being, we are coming one after another. The predictive analytics for the demand forecasting by utilizing the AI and machine learning. It's a kind of the Iris digital platform. In collaboration with Accenture, the BPCL has developed the Iris and AI-powered digital platform in supply chain management. It integrates the real-time data from its extensive network and including over 18,000 fuel retail outlets and 25,000 trucks. So this is nothing but this is processes the inputs from per second from the automated RFID tags, sensors, cameras, and IoT devices, and it will remote monitoring the real-time demand, inventory, and management. Automated responses to the equipment failures or hazardous situations are also being reported into the system. The other one is the digital twin for the refinery operations. The same kind of technology, IOCL has partnered with Algoid Corporation, a leading provider of AI digital twin solutions. They are providing this kind of simulated digital twin package for the FCC WinMax unit for the refineries. This emphasizes for optimizing the refinery processes and enhancing the operational efficiency and sustainability with the real-time data analytics. Third one is the cohesive digital solutions for project execution, including supply chain management. So this is basically, it is under implementation. Rather, already we are the master system integrator has been finalized. So this is basically our upcoming Bina Petchem refinery projects by the BPCL, wherein Engineers India Limited is also been associated. The major part in this in the supply chain management is it is going to integrate the Primavera schedule and the digital progress monitoring system for capturing the regular progress at manufacturer shop and the site. The second one, which is the entirely new thing, that is the digitalized quality inspection status monitoring and storing the digital copy of the quality inspection itself at manufacturer unit as well as in the shop. Utilize the cameras and AI-based analytics to ensure the safety and risk mitigation. And finally, utilize the GPS for centralized monitoring and tracking of LLI and ODC equipments. Now, so from all these slides, it is apparently prudent that the companies which are going to commit to the digitalization for the supply chain management, they ultimately they are going to save their supply chain assets, cost optimization, etc. But irrespective of that, digital supply chain solution in the refinery petrochemical sector also come with a set of risks, which is basically carefully managed to ensure the long-term benefits. The number one is the data integration and the interoperability. Here, all the stakeholders are working in a single platform. So, if the data are in different various sources, either from the client end, either from the manufacturer end, either from the TPA third party end, it is not coming properly. The lack of integration leads to the data silos, and inconsistent information is directly going to hamper the supply chain management. The same could be overcome by the unified platforms, by the API related customized APIs and all other things. The other one is the data quality and accuracy. See, here every data is coming through the remote sensors and remote operability system. So the real-time data update is very much required. So because the poor data quality can result in the incorrect forecast, project delays and budget overruns itself. So the solution is for each and individual end user has to maintain the strict data governance policies with the master scale integrator, so that the real-time data should be used for any data analytics or predictive maintenance. The third one, which is the most important, that is the cybersecurity and the data privacy. Cybersecurity threats in the digital platform can lead to the operational disruptions and subsequently affecting the project timelines and cost. Here, the end users, whoever is going to implement the digitalization in their supply chain management system, they have to abide by some compliances. Maybe like that, there must be some uh, you can say that ND agreement should be signed between the customer and the other parties. The data center on which the application, the cloud-based system is going to be hosted, it should be in India. If even though it is not in India, there may be some specific reason for that. The cloud service provider or the data service provider should maintain the accreditation of MEITI empanelment. MEITI means that is the Ministry of Electronics and Information Technology. The vulnerability yearly, the vulnerability assessment penetration testing should be there, and it is to be ensured by level 1 and level 2 by the master scale indicator itself. And this should be done in the CRT in empaneled auditor itself. Usually, wherever the cloud related system has to be there, or from any of the master system integrator the cloud system provider is going to provide, they must be certified with the ISO 27001, ISO 27017, and ISO 27018. 27001 is basically for the information security management. 27017 is for code of practice for the security in the cloud system, and 27018 is basically for the code of practice protecting the personal information. So majorly, if we go for the digitalization in the supply chain management, we can come to a conclusion that embracing a digital supply chain is not just a trend, it is a necessity for industry today to aiming to thrive in a competitive landscape. By leveraging the technology and the data, we can create a more responsive, efficient, and customer-focused supply chain through digital supply chain management. Thank you, sir. Thank you very much.
Thank you, Diman, for your very good presentation. So, uh, it is needless to say that the digitalization of many logistics and supply chain is going to happen maybe over a period of time, but it will not only reduce the cost, increase the efficiency, more importantly, to reduce the emission. So I think very informative presentation. So our last presentation today is by Mr. Shashi Shekhar from IOCL, and very different presentation than what you have seen today. Supply of 60 Hajj shore power to extreme vessel in the Harit Sagar policy of the government of India. So Shashi has graduated in marine engineering from Marine Engineering and Research Institute, Calcutta. Currently working with IOCL at Paradip, Odisha, and good field experience in tanker operation, port, and SPM maintenance. So Shashi, please go ahead.
Thank you, sir. Good afternoon, ladies and gentlemen. Respected Gautam sir, my fellow speakers, dear delegates, it's a privilege and honor to put up my thoughts and present on how shore power can help in achieving the debated topic of energy transition, energy affordability, net zero, in the context of marine operations. I hope my presentation opens up the field level dimensions, equations, and the dynamics which are involved in implementation of the shore power concept when we talk of the large scale EXIM vessels, which has been very much in vogue for quite a while in the Western economies, but not much in India. This is not a new concept. Shore power is being used in India for the small port tugs and some naval vessels. But to see a visible transition on, we need to we need to figure out how can we implement it in the commercial on the commercial scales in the commercial vessels. And since I belong to the oil industry, I will put my thoughts in the context of the product tankers which we operate of say some 50,000 deadweight tonnage at our oil jetties. In Indian Oil, it is in Paradip, Kandla, Chennai, and even in Kochi, we have our own jetties. So I'll put my thoughts in that context. Uh, Let me just begin by making an opening statement to set the tone of the presentation. India is en route to achieving power surplus scenario, and energy transition has long been pending in the Indian ports sector. Embracing shore power will drastically bring down the cost. We'll see how it will bring down the cost of the electricity which is used on board whenever the ship is docked at the jetty, resulting in a lower freight structure, as well as will also bring in high-end foreign consumers to the grid. This is an important point because we all know how Indian power sector, particularly those power plants which operate on natural gas and imported coal, they are just not running because the power which they produce, no one is ready to buy at the cost at which they produce. Um, so we have a um, consumer which can actually afford that power, that is the shipping industry, which will further drive the power demand and will aid in achieving the net zero goals. uh, I will put the presentation in specific context of the oil jetties at all major ports, the product tankers, and I will put a specific use case for the time charter product tankers which are being operated by Indian Oil. We'll discuss on policy guidelines, then the technology which is available, the viability of the proposal. Policy has been quite okay, I will say. Why I am saying it okay, because the policy which has been issued by Ministry of Shipping hasn't been fully ratified in the schedule of rates SOR of the all major ports. There is a Maritime India Vision, then COP26, and as we saw in the first presentation, the Sustainable Development Goals, that is the 12th goal, climate action. We need to find low carbon sources to provide energy to the port sector. So this shore power is obviously a low carbon source. Technology is available. We have got shore-based static frequency converter, which can supply the 60 hertz power. The This is the biggest technical hurdle which we face, because in India, as we all know, we operate power, or we generate power at 50 hertz of frequency. All the international vessels, not only the international vessels, even the Indian tugs, port, the entire maritime sector operates on 60 hertz. So we need to find a way out to convert the Indian 50 hertz power to 60 hertz power at a scale which is being required by this product tankers. The system has to be logistically convenient, it has to be safe, it has to be compliant, it has to be affordable, and at the end of the day, both the parties have to make money out of it, otherwise it won't run for a long time. Viability, yes, it is viable, because right now all the ships which dock at the jetty, at least I can say for India, all the ships which dock at the jetty, they use their own diesel generators to generate their power requirement. The cost of the power which is being generated by using the generators is somewhere 20 to 27 rupees, 28 rupees per unit. If I switch off that generator and I connect the grid power to that vessel, the cost will come down to 12 rupees. So this is some 60% reduction in at least the jetty operation cost. There is capex and opex involved, which I will show in the for this slides. The cost of the converters and the shore power container can be shared and figured out, and it is absolutely pollution free. If you can provide the renewable power to the ship, then it is absolutely pollution free. If you are providing thermal power, then you are doing some pollution at the thermal plant point, but that is lesser than what the ship will do when it will burn diesel in the generator. We will discuss the hurdles. Then is again this chicken and egg problem. Who will set the facilities first? Will the ship owners take the first step, or will you take the first step? The cost of the power element gets conveniently passed on, and since uh, the power which is being used in the ship while the ship is at jetty, that cost is built up in the freight structure. So it is right now, it is actually not a problem, but yes, the operations become costly. And the technology is new to India, so we will discuss these hurdles. We'll have some insights from the ports where this system is running successfully. One very good example is the port of Long Beach in California. Um, we have some insights from the power sector. As we all know that the gas power plants like NTPC Anta, Kayamkulam, NTPC Janor, NTPC Kavas, the plants which run on imported coal like the Tata Power in Mundra, they all are running and at a very low PLF. The reason being, the cost of the power which they produce is so high that the normal Indian consumers can't afford it. And even the renewable renewable energy is available in India, but again the cost. We need someone who can afford that high power cost. Since the ships are using even more expensive power, so I assume they would be happy to use a power which is lesser expensive than their current power of DG power. And we have a case study from California Air Resources Board. We have a case study from Tuticorin, where recently ABB has commissioned India's first ship-to-shore power supply on a commercial scale. And we also have a case study from JNPA, who is they are implementing a big project to convert few of their jetties to shore power. So what is actually shore power? Whenever a ship is coming to a jetty, it needs to run its pumps, compressors, air conditioning, lighting. There are many systems on a ship. So all these systems require power. So either you take power from the shore, which is right now not being done, or you generate your own power, which is being done. And I propose to make the system as such that they should switch off their generators, take power from shore. Since they need 60 hertz power and we produce 50 hertz in India, so there has to be something in between which can provide that 60 hertz power to the ship at a in a way which is quite compatible to them. It will reduce the cost, it will reduce the pollution, it will reduce the freight, it will enhance the port and sustainable performance. And this is clearly spelled out in the Harit Sagar policy launched by Government of India a couple of years ago. Policy strengths, yes, we have a policy. The Harit Sagar policy issued by Ministry of Shipping mentions that all major ports should be ready with shore power by 2025. Now I have read that this target has been stretched to 2030. Maritime India vision also requires that the port should increase their share of renewable energy in their energy basket by 60%. Saying this is easy, but as you know, renewable energy is costly as compared to the thermal energy. So you will need to find out a way of finding people who can afford this expensive electricity. Oil marketing companies have got ambitions of achieving net zero goals by 2047. And of late, the government is actively pushing for bringing the maritime sector in the fold of the energy transition. This shore power concept more or less addresses this particular ambition. Policy what do I expect from policy? That the common that there should be a mechanism to share the cost of the fixed static frequency converters. There should be some policy incentives or cesses on oil marketing companies. Otherwise, why will they take the first step? There has to be a fixation of power tariff. They should know the power companies should not be allowed to take advantage of the situation. And this has been spelled out in the policy that all the players who will adopt shore power, they will get the due concessions in the both in the port charges and in the berth dues. Uh, but this particular thing has is yet to come in the schedule of rates of the major Indian ports. Uh, the technology details, it's a very simple system, and right now it has been improvised as such that it is compatible for the vessels. There is a static frequency converter. We convert from AC to DC, and then again you convert DC to AC. And while we are doing that through the silicon control rectifiers, we change the firing angle as such to get that required frequency of 60 hertz. um, it minimizes the operations and maintenance cost. It high reliability, provides maximum power, keeps the equipment running through utility voltage sags and frequency variation. uh, these are the major features of this static frequency converter, which has been made running which has been commissioned in Tuticorin. It's a small system. It's a containerized system, so it can be shifted from one place to other place. So there are control modules which take care of various parameters. Uh, Module it is, as you can see the line diagram. You need to install two different systems, one on the ship and one on the shore. So shore side, shore connection box is there, which has got the frequency converter. It has got a output transformer. It has got a cable management system. The standards which govern this is IEEE 80005. It has got each and everything all the points are well written over there, which takes care of the compliance issues. And this is an international standard which is being used by all the ports which use shore power. And then we have IEEE 1580, which stipulates the recommended practice for single or multi-conductor cables. What kind of cables you want, armor and the jacket. The ship also has to be ready for using the shore power. So we will need to extend the main busbar to the emergency generator room from where the connection can be made. There is a ballpark figure. This retrofitting will take 2-3 days, and it will cost you some $100,000. Then at the land side, we need to do this. We need to put this container, which will have all the systems, which to convert the 50 hertz incoming power to 60 hertz power, which is required by the ship. The ballpark figure for this installation is around $500,000. There are hurdles, yes, reliability of supply. The supply has to be, you cannot afford to do some load shedding over there. Then the capacity of the shore connection box, that is the ship side retrofitting which I discussed. Power should be available. And billing modalities, how will you bill, how much tariff will you charge for the shore power. Then since the ship owner is going to save some money since he won't be running his diesel, so there has to be a clause in the charter party which will give due incentive to the charter if this system is being used. This is for us to see ship sides first or land side first. What and to solve this issue of chicken and egg problem, that what people are doing elsewhere. Like I have a case from China. There are financial subsidies, tax reductions, duty exemptions, and technological assistance which is given to both the parties, that the ship owner as well as the jetty operator. Why I say it is viable, because as we can say, I'll just move on to the next slide. Yes, as we can see in this, suppose there is a product tanker. It has got 3 generators, 900 kVA, running for 48 hours of port operations. And if you take 10 operations in a month, so you are going to consume some 12.96 lakhs units. And the electricity bill will be coming, if you take 7 rupees per unit, it comes out to be around 1.07 CR. Whereas if for the same amount of electricity, if I can just have a few more minutes. Whereas for the same amount of electricity, if you burn diesel, then I have taken the figure from a product tanker, it will cost you some 3 CR. So, and in time charter vessels, the responsibility to supply the diesel is with the time charter, that is for Indian Oil. So, instead of supplying diesel over 3 crores, please pay the electricity bill of 1.0077 CR. So, there is a 66% savings in energy cost if shore power is made available at the existing tariff rate. Um, as I mentioned, these plants are not running, the gas power plants as well as the imported coal plants. Power is surplus in India, but affordable power is still not surplus in India. So Government of India, Ministry of Power, they have made this surplus power portal, in which all these consumers who intend to buy this power, they can put up their demand a day before, and then right now the capping is at 12 rupees per unit. Emission reductions, this is just an illustration of how you will reduce your emissions at the port by using shore power. There are system risks, but then we have figured it out. We will do the load bank testing, then we will perform the safety test. The system will be carried out, it will under the controlled conditions while the vessel is at berth. There is a cable management system to take care of the tension in the cable. If the weather is rough and the ship is not so stable, then before something goes wrong, we will have an alarm. Uh, the port will have to augment their power infrastructure. Right now, they are like Paradip, for example, they are equipped only for 3.5 MVA. One product tanker alone needs 2 MVA. So if you are if you are planning to handle, say, 5 tankers, so you will need to augment your present capacity at least by 3 times. Kanla port is also at the same page with the Paradip port, so that will also need an augmentation. Um, this is again, the JNPA is making a project. They are doing a project, and we are expecting to go live by 2030. They are augmenting the capacity by 74 megawatt. Case for Indian Oil, as I explained, all the time charter vessels for which we supply the diesel for the generators, we can plan to put shore power systems, which will save the diesel outgo and will also save the bill for the oil marketing companies. Power sector insights, yes, this has been a matter of concern. All the gas power plants are lying idle. So all these plants need a consumer who can afford this power. I think the merchant shipping industry is in a position to afford that power. We all have a JV with Indian Oil and NTPC. NTPC is the best company who knows all this technical stuff. IOCL has got all these product tankers, so I personally feel that this JV can help. And this is the closing statement that the policies will definitely bring the shore power, but sooner the better. Happy to take your questions. Thank you very much. That's from all from my
Thank
side.
you, Shashi. An excellent presentation. So, just to summarize, very good presentation, 5 presentation, 6 speaker. While Minal talked about the Gale's innovative idea of actually obviating Red Sea crisis, Paramjot talked about vessel optimization, Shashank and Neeraj, of course, a very important topic of sustainable procurement. Dhiman talked about the digitalization of marine industry, and finally Shashi Shekhar about the powering of vessel from the port. So I think very interesting presentation, and the audience, our speakers are available after the session. If they have any question, kindly connect with them, and they'll be happy to reply to your question. So thank you all very much for this session, and looking forward for such discussion in some future events. Thank you.